So our presentation is on the electrical energy transformation involved with hydrolysis. And for those of you who don't know what hydrolysis is, it is when we take positive and negative electrodes and insert them into water. And what that does is the flow of electrons through the water breaks it up into hydrogen and oxygen, and it forms bubbles in the water, and then once you stir that, it'll evaporate. So it's kind of like evaporation through electricity.
Alright, so our developing question was, how do we measure the power involved in breaking apart bonds of water? And to get started, we set up our station, which was a power supply, water, and the electrodes. So to collect the data, we put the electrodes in the water and turn the power supply up so that it would be releasing 30 volts into the water. We had the container of water on a scale to measure the amount of mass loss over a period, and so that would measure how much bonds would be separated over a period of time.
And we would later use the mass of water lost in an equation, which involves something called bond dissociation energy, and we'll get into that later. Alright, so to analyze and interpret our data, we needed to see what the graph of this data looked like, and we'd expect it to be linear, which we found it was for the most part. This test that I chose to put on the graph was the most accurate. Some of them actually, we gained mass, so that is one of the points that I'll talk about in a little bit. We're really inaccurate with our data collection. The scale is really inaccurate. But this is the test that was the most linear, which should be the case, obviously, because we're subjecting the water to a constant amount of electricity. So since this was the best test, we decided to use this for the rest of our presentation.